Good afternoon, everyone. In today's lecture, we'll be talking about characters and text. So, in this particular lecture, we will learn how to use char in an advanced level, or how to master our char. And for you guys who doesn't know what char means, I'm going to explain what char means. So, in this lecture, what are the benefits of this particular lecture? Yeah, we will learn what the char data type is and how it stores characters. So in the next thing we're going to learn is that how characters are represented using ASCII value. So we also learn how to use character arithmetic, which means see how to manipulate characters with simple maths methods. Just simple maths, simple maths, not really a hard one. So we also learn how to master escape sequence, like using of common escape sequence like /n and /t. For you guys that doesn't know what /n and /t means, so we'll be bringing what that means in this particular lectures. And also we will also learn or understand or gain what to apply useful functions, like learn essential char functions like to uppers and to lower. So those are the features you're going to benefit from this particular lectures. And the last one is handling of strings. Get a basic intro to using of chars and array to store string. So these are the benefits that you're going to get from this particular lectures, and more than that. No, that's not everything I'm going to bring to you. So I'm going to introduce more than that, but for now, I want to open up this to you guys too. And the next slide here. So if you look at this first text we have here, we said char is the naming type for characters in C++ language. So when we have our first topic here, we said characters and text. So now what character means is it represents char, which is char. This is the data types of C++ program language, which means character. So character is being used as char in C++ program language as a data type to store a single text character, a single text value. So you can only store a single text value in char. And what does char do? Char actually give you the permissions, or give you the permission to use the value of or single value using a single quote. Like what we have here, we actually have char, and we have character 1, which is the variable, and we have the initializing part, which is the curly brace, and we have single quotes here, and we have the value of a, and we have the closing of the single quote, and we have the curly brace close and the semicolon. So what does this one tells us? That it means that we can actually store a single value or a single characters in your variable, meaning that you can actually store a in a variable. You can store a and b. The compiler throws error. You gotta get compiler's error. So you can actually choose two characters, or you can actually insert two characters in a variable when you are using char. So it has to be single. Single character. So that is what char does. It stores a single value. So I hope you guys understand that. So now we actually stores more than single value here, which we have to declare. We declare the variable, and we have the character first one which stores a, and we have second character store b, and we have the one store c and d and e. So that is the way you use your char. It's used to store a single character in your programming language. So in the next slide here we have so char actually is a data type that actually takes 1 byte in memory. We have actually been talking about the size of data types in memory. So char stores 1 byte. And what does I mean by 1 byte? 1 byte actually means 8 bits. 8 bits in memory, which is the zeros and one, which is the binary you see here. So it stores 8 bit, which is 1 byte in memory. And we should extend this more. What does the when we talk about 1 byte, what do we really understand by 1 byte in char? In char, I mean, so what does this mean is that 1 byte is 256 possible value. So what this means that you can actually store 200 and like this char here, this value we have here, you can actually store up to 256 possible value in your character, match to each characters, I mean. So you can actually store this particularly to each character. So that is how chars works. In memory, it stores 1 byte, it stores 8 byte, I mean, sorry about that, I mean it stores 1 byte and 8 bits in memory. So don't get confused, I'm sorry about that. And so a byte is 256 possible value that you can store, which we have here. We have this is, let's say this is just 1 and this is 2 and this is 3. So we can actually store possibly of 256 value in it, and which is 1 byte, and 1 byte means 8 bits. Sorry, don't get those things confused. So bit actually means a single one you have there. So a single bit we have here, which is the binary, is called this is a bit here, a bit here, a bit here, and the whole bit here consumed, I mean the whole bit we have here is just a byte. So that is the amount of memory char can actually contain or can consume in your binary format. And we should move to the next slide here. We actually have a simple text here, and it said, however, there are 2 kinds of char types in terms of signage. Will you guys, if you should get me or understand, I've been following this lecture, or you have heard it somewhere else, or you have learned about that. When we talk about sign and unsigned, we know that sign is used to store both negative and positive value. But when we extend this, we can also store only positive value when we use unsigned char. So signed char actually stores the value of minus 128 to 127. So it stores both negative and positive value, and the left bit is used as a sign bit, determine whether the number is positive or value or negative. So the most occurrence of the bit, I mean the most occurrence of the in binary format, I mean, so the most occurrence value is used as it's either determining if it is positive or negative, but it's, let's say, the most significant bit. The most significant bit is actually put in whether it is in char's location, I mean in char's in sign location, which means that we can actually store positive and negative. And when you are using sign char, so the most significant bit, it is either stores as positive or negative, which is from minus 128 to 127. So if you extend to unsigned char here, sorry about that. So if you extend to unsigned char here, so if you extend to unsigned char here, so it talks about, like, we can actually store the value from 0 to 255. So all bits are used to store a magnitude value of, all 8 bits are used for storing the magnitude of the value without any sign. So it stores negative value, it stores the positive value from 0 to 255. So I hope you guys understand what that means, if not too much. So just don't, though this is not this is just to go deep into this particular one. It's gonna take time, takes a lot of time. So I'm gonna explain that in a very brief way. So if we should move to this, next slide we have here. So now we're gonna understand how those things, how those chars has been represented. It's been represented or translated in memory. So we have this present table here. This what we call ASCII table. So we have ASCII table here, which actually link both the decimals. I mean, which actually shows both the decimals and the chars in memory here. So let's say now whenever we use char of b. Sorry about that. Let me zoom this thing clearly. So whenever we use the value of b, the capital letter B, it is represented as 66 in memory, or in sorry, let me just be specific. In decimal, it is being translated to decimal in 66. So don't worry, you're gonna understand what that means if you get those still get me. So now we have, in this particular one here, we have A. So this is known as chars and char, and it has the value of this. It has the variable of character 1, and it is being stored as A. That's the value. And when we go to this, slide here, we have 66 and we have B. We have 66 and B. Sorry, let's just close this. Let's be specific. A is 65. So A is what? A is 65. So when we have A stores, sorry about that. So now let's clear this. So when we have A stores in your programs, or do we store capital letter A? I think we store small letter A. So let's be specific, and the value is not the same thing. Let's just go to the specification, the specified one. So now we have the value of B, and we have 79. So if we should use chars and print it in your program, we print it in your program. It's going to print out A. No, on the norms it's going to print out, or particularly it's going to print out a character. But if we should convert, or it is being translated as 97 in integers, or it's being translated as 97 in integers, so we're going to understand what that means, how they are being translated in integers. So using our ASCII table, so we can actually have the value of 256 stores in here. We can have beyond and we can have below. We can actually have the value of 256 stores in our character. And if you want to look up to this particular but maybe you might need this specific to check or to understand more about ASCII table, so you can actually go to this particular site there. It is being made for you there to get and understanding more. And if you should go to the next slide here, we have some simple text here. So it said it is possible to assign a valid ASCII code to a character variable, and the corresponding character will be stored in. You can actually you can choose to interpret either as character or as integer value. So whenever you use your let's go back to the first one. Whenever you use your char, or declare your chars and give it the variable and use the value, you can decide whether you want to use it as character or you want to use it as integers by manipulating x in your program, by manipulating this. So you can actually manipulate this particular value here. Sorry. So you can actually manipulate it, whether it's going to print this specific value for you, or to print the one in integer value. So if we should go back there, and that is, you can actually manipulate it, interpret it either as characters or as integer. So the next one said sorry, the ASCII encoding. Now if you don't know what ASCII means, it means American Standard Code for information interchange. So that is what ASCII means here. So what does let's try and understand more, a little bit more what that means. So each character corresponds to a numeric value between 0 to 127. So for example, A corresponds to ASCII value of 67, like we actually bring up in our ASCII table here. When we use A, we see what A is. A is actually what 60. So A is actually sorry, A is actually 65, or sorry, is it a okay, it's 65. So cap letter A, capital letter A, which is capital letter A, the cap A, the uppercase A, or whatever. So the A actually is being interpreted as 65. The A is being interpreted as 65. I hope you get what I mean. So A is actually interpreted as 65. And when we move back to, sorry, I'm still on ink. Sorry about that. So A is corresponds in ASCII value, it corresponds to 65. But when we go to the next one here, next line here, we have different thing. We have small letter A corresponds to ASCII of 97, which we actually have shown, which have been shown here. So the value of A, the cap A and the sorry about the board. So the value of the cap A, why is this stuff good? Like, so the value of the cap A and the value of the little small letter A, they are different. So whenever you declare A, or whenever you use A, you have to be specified, or the purpose, you have to be purposeful about what they are actually doing for you. So the value of 65 and the value of 97, they are actually different. They are different. They are actually different. These two values, they are different. They are definitely different. This is lowercase and this is uppercase. They are absolutely different. So now we should, sorry about all this. Let's go back to the slide. So so now 0 here, it is, or even put in a single quote, it is corresponds at 47. Let's try and go there. Let's try if it is 0. Okay, sorry, it is 0 here. So this is it here. 0 here, which is this is it. So 0 here, 0, and it is represented as 48. Sorry about that. So it is represented as 48. So 0, it is represented at 48. So that is how our ASCII encoding happens. So ASCII character is between 127 and 256. Actually 255. Is this 255 or 256? Copy. Is 256 actually. So it's 256 are often used for extending character sets like symbols, set characters, and but as standard across all systems. So definitely you can use this across all systems. You can actually use this across all systems. What does that mean? So we're gonna explain what we're gonna understand what that means. In I will point that to you. Well, we're gonna understand what that means. Why we can actually use across all systems. Okay. Sorry. Okay, let's go here and try and understand something. So here we have char, and we have the value of 67, which is stored as C. It's stored as letter C in the characters. In characters memory, so it's stored as C. So when we print, if we should print this particular out, it's going to store the value of C. It's going to store, because we are using the data type of char, and it's going to store the value of C, because in the char ASCII table here, 67 actually means C. So which we see here, 67 actually means C. So it's going to store as C. That is what the compiler is going to do. It's going to store it as C, because the value, because the data type we have here is chars, and it's going to take this value here and store it as C. So now we will print it. It's going to give you C, and now if we should manipulate the data here, so we're going to manipulate the particular data here. So we're going to either use stats cast and use integers, so and use this particular code this way and put our value in the parentheses. It's going to convert the value of C. Only once we have declared 67, but we use the data type of char, so it's going to convert this data, this particular value, to C, which is char, which stores characters, and we can actually manipulate it to integer by using this stats cast and int. So we automatically convert to 67. And if we should, or we can actually do it in this way to make it simpler, we can actually do the value of value integer, and you can actually just use your int and just open your parentheses and just use this one. It's also the same thing. You can also make it simpler by using it in this particular method here. In this particular method here, you can use both, either one of these two. They are doing the same job actually. So sorry, I think I skipped something. Okay, so to wrap this up, or to wrap this up in this particular section here, so it falls short when it comes to representing language other than English and in Western language. So what this means is that, when you are using your text in Arabic and Asian language like Japanese or Chinese, it doesn't comes up like English. No, this is just a simple text we have here. A simple text we can actually have in, this is an A. This is particularly A. This is letter A, which actually represents or English language. But when we extend our knowledge, or when we extend our language to other languages, which is not this American, which when I explained, I actually talked about this is just an American standard code for information interchange, not Chinese standard code for information interchange, not Arabic standard code for information interchange. So it is for Americans, and it is been American encode information. So if we should use it in this if we should introduce this language, which is Arabic, Eastern Asian language, or Japanese or English, there are different ways, of using it in we can actually use ASCII for it, and definitely it will not work because they are special characters. Japanese language could be different, and Asian language could be different also. They are represented in different methods. So definitely there are better ways to represent text that are meant to be seen in different languages. One of the most common is being Unicode. So you can actually represent those characters like the Japanese and Asians and Arabic. You can actually represent them in Unicode instead of using it in ASCII, which is only for English language, which we know about that. So we can actually use the same characters we use as this in English for the other languages which we have here. It will possibly not work. It is going to throw you error, and it definitely won't go. It will not work, definitely. So, and these details of the code are out of the scope for this course. So we won't be discussing Unicode in this particular course, because we are actually talking about, we actually going or looking forward to ASCII, and we are not particularly learning or studying Unicode here. So this is out of the lectures, and we won't be talking about that in this particular lecture. Just to know that this is a robust way to represent text in different language for your computer. This is just to show that there are other ways you can actually represent your text in different language, which is Unicode. There are other ways you can represent your other languages, which is Unicode. Definitely using your char actually. So these details of Unicode are out of scope for this lecture, which I actually explained that just to know that it is a robust way to represent text in different language for a computer. So I hope you guys understand what this means, and I hope you understand what char means, and I hope you understand that char is used, or let's to summarize this, to bring this to a very brief way. Char is used to store a single character, not two characters. If you are storing A, you can store A and B. If you are storing C, you can store C and B. So it can also be translated to integer, and you can also use in terms of signage, you can also use unsigned, and you can also use sign, which actually goes after being positive value or negative value or only positive value. So I hope you guys understand what this logic actually means. And for you guys to understand more, we're going to go to the Visual Studio, and we are going to use most of the system we have here, and let's try and work on Visual Studio. So here we're going to declare what we are using. So first thing, we're going to declare char, and we're going to use characters of single quotes, and we're going to declare a, and let's just print and say sorry about that. So b, and so we're going to store a symbol. Sorry, I will declare this. We're going to store a single character, a single value. Let me zoom this stuff. Okay, so we're going to store a single value in our variable here using the data types of char to store it. And now, if we should print this simple specific code, it's going to give us something very simple. So if we should print this stuff here, so sorry, or let's say character a, character 1, sorry, so I'm not convenient, so that's one of the reasons why I'm not typing properly. So let me just copy this to make it easier, and so we're gonna say character 2 and the value of this, and this is gonna take our time again when we run our code. So if we should run this code specifically, it's going to, oh god, I have zoomed everything out and everything is gone. So now I'm going to use terminal and build. So we build this. After we build this, it's going to generate our binary, and as usual, so it should not be very strange to also, oh god, something happened right now, and which I shouldn't have missed. So it's going to do as usual, generate our binary, and after that we're going to run and see exactly what it does in this specific variable. And let's just try and hold on and let's check it out, what's going to happen to our value here. So I am expecting this to really, I'm expecting it to work very fast, but like usual, you have to be calm, and you have to take it easy with. It's taking your time, and as that is taking our time, so let's try and do some. Okay, let's try and hold on. Let's try and hold on for it. Okay, so I want to take this lectures. I want to take these lectures, in a very easy and calm way, so that I'll be able to pass my message. I'll be able to pass all my message in a very frequent way. So I'm going to check what is being printed or what is being stored in our value. So now let's try and do something. So code lab, and so fine, we have the characters of we have this character which is here, which is stored in the strings, and we have the value of a, and we have it is stored here. So we understand that we can actually store a single quote. But now let's try and do something. Let's try and manipulate, or let's try and do something really naughty. Let's do something that is out of the scope. Now we know, or we understand that I understand that I cannot declare or I cannot use more than a value or a single text or a single character in a quote when I'm declaring a char. So I'm gonna do something crazy. So I'm gonna store two character here, and let me run it again and see what is gonna happen. So I actually stores two specific characters. So I store A and B, and if I should run this, my compiler should give me error, or it's gonna be compiler error. So the compiler won't generate binary format for us, so it's not going to be runtime error. This is going to be compiler error. Yes, so now you see what is coming up here. So it's see what is coming up here. So it's not generating my code for me. It actually, you know, proclaimed error. Like I use I use multiple characters. I use multiple characters for just for char, which is not possible, which is not making sense. So I am actually making out of, like, I'm not making sense when declaring stuff like this. So do not use do not use multiple text or character in a char. So just single is okay. Whenever you use something like this, it's going to throw you error. So I want you guys to understand that it's going to throw error. So now the next thing we're going to do is going to manipulate. So let's try and, you know, manipulate chars, and let's convert it to let's try and convert it to integer. So now let's try and look what is in, or what is stored as a, what a represent in ASCII table. So let's try and understand that. So we're gonna do, we're gonna say std. So we're gonna say or let's try and use the same thing we have been using. So now I'm gonna say value 1 on, then we're gonna say integer int and int. So yeah, this is what we're gonna do here. So we're gonna do text cast or static cast, and sorry, it has to be underscore, and then we put an angle bracket, and we're gonna put integer and put this in a parenthesis, and this stuff should be converted to the value that's integer. It should be converted to integer. Whenever we print this, it has to be converted to integer. And let's do the same thing to this, but we will use this method. I will use the other method which I told you that we can actually convert them. You see that we use or. Let me show you guys so you can understand what I'm actually saying. So I said we can actually use or. Where's this stuff up here? Sorry. I'm trying to locate that stuff again. So yeah, I said we can actually use this particular to convert the char into, though definitely we did something really, I can actually convert it. We did something different there. What we did different is that we did chars and we have the value, and we store integer value here, but we store integer value here, but in our code we store character value, so we can change it actually. So for you guys to understand that we are still talking about the same thing. So what I actually want to say is that this value here is stored as static cast and integer and int, and we have value here, and these two things are doing the same. So I'm going to use these two for the code, so in order to see that they are actually working the same way. So I'm going to use the same thing here. So now though I will still change this to integer, so in order to get that, so let's try and run it here and see what it's going to give us here. So by our sense of thought, you should know this is run and it should be converted to integer value, and they are meant to convert to integer. So if we should hold on and take it calmly, we're going to understand, or we're going to see how this is going to be run in or it's going to be generated by our compiler. Good, and let's just try and see what is there. So now good lab. Okay, good. I like this. This is very good. So now we have characters of value. We have character 1 value, which is integer. We have 97, which we store yet, and we have a character 2 value int, which is 98, which is also stored here. So you see that these two functions, they worked exactly the same way, and they actually print our value out the way we expect, because we expect this to turn or to convert them to, or to convert it to what? Integer for us. So now for you guys to understand that the one we bring in our code, so we're gonna make it up here. So let's use characters of char of char of character 3, and we can store maybe like 54, and let's print this. Let's look what's going to be printed out. So let's try and print 3. So we will store what? We store the characters of character 3 there. So what is going to happen here is that it will give you 53, because you are using the data type, or you are using char data type. So it will give you the value which is represented in ASCII table of char. So let's even try and check what the value is going to be by going back to this side here. Let's look for 53 here, and let's try and formulate, or let's try and get our answer even before the compiler does. So 67, let's look for 67 here. 67 should be what? 54, I mean 54 should be 6. So it's gonna be 6. Let me try and show you guys. So 54 is 6. So in char here is 6, and in decimal here is 54. So I hope you guys understand what that means. So in our particular code here, we have char here, so we have the memory, and we have char store 54. So this result is going to be 6. So if we should run our binary format again, we are going to get 6, the value of 6, directly 6. That's to the 6. So let's try and hold on and check how this thing is going to be printed out. So let's try and hold on. Sorry. Okay. Okay, good. So we have the first character, the value integer. We have 76. We have we have 97. We have 98, and we have 6. Like, which we have known even before we get the answers. We already know that it's going to be 6, because we have the char here, and we have the variable, and we have the data types of 54, which is being stored as 6 in char's address, in char's address. So in the memory address of char, when we use 54, it stores as 6. Sorry, I think I'm a little bit confused. So okay, when you use the value of 54, sorry about that. Okay, yeah, 54, 54 is stored as 6 here. So that is how it's been stored in sorry about that. So 54 is stored as 6. So we can actually try the other value. So we can try, like, okay, let's try something like 100. Let's try 100, and let's run it, and let's see what's going to be out. Okay. So, and before after that, we're gonna understand a little more about unsigned and signed char. So we're gonna understand signed and unsigned char if after this particular sample. Okay, good. We have small letter d. So by using 100 actually stores the values of 100 in decimal is being known or translate as char, is being translated as d, small letter d in char's address. So you see how they have been, changed and used interchange. You see the way they have been interchanged in their memory. So you do from the ASCII table, you see the way they have been interchanged. So next one I want to show you that how to just get unsigned chars. And so we know that unsigned is actually positive. So when we are using unsigned, so let's say characters of 5, and then we use that's positive. So we can actually use negative numbers. So we can just use positive. So we can let's say 90. So so if we should run this again, and sorry for running again. So if we should run this again, we're gonna get something really common, because it you should expect the conversion of this particular character to char, and since we use unsigned, it's not going to give us error. So but we're going to do something really crazy also. So in order to know how you encounter error and know how you solve the errors, and first after that we're going to use instead we won't declare sign, so we just use negative negative value here. So now we have z, which is z. Yep. So it is known as z, which is 90 is known as z, which is unsigned. Still the same thing when you are using a char. So but let's try and use negative value, which is minus 90, and let's try and run it again. So it's going to give us error actually, because we are definitely doing something really crazy. It should definitely give us error, and to be able to encounter and solve the error, you have to make it signed, not unsigned. And sorry, I'm coming. Let's try and hold. Okay, it's built successful. Okay, this something is I'm coming. Sorry. Definitely, I haven't really passed my code. Since it has run, I'm coming. Let me try and run it. Let's check what is there. Okay, yes, giving us special character. See, the character we don't really expect this. It's giving us special character actually. If you should see this properly or boldly, this particular one here, it's really not making sense. It's out of scope. Like I said, it can be out of scope. Let's try and check the explanation. The explanation we have here. Okay, here we have it here. So we said ASCII character 128 to 255 are often used for extending character sets like symbols and special character, but aren't standard across all systems. So they are not already standard across all the system actually. So now we have actually going out of we have to actually print out of the scope thing. We are actually having some kind of some different text, and this is really not expecting. So we don't expect this, and let's try and use just sign as well. We should print definitely. So carefully we will try and understand that means. So charts. Okay, good, it's built. We expect it to build because it is of the same type, and okay, the same thing actually, the same thing. So I think there is no problem with using something or stuff like this. It's, let me try and use this first. And maybe it's not really recognized, so let's try and check something. I think it's gonna print out. It's gonna give you the same results. Definitely, it's gonna give you the same results. But what I want you guys to understand is that the character from the difference between sorry. So what I want to understand that in the signless matters, it can store from minus 128 to 127, and the unsigned chars can actually store the value of 0 to 255. Yes. Yeah, the reason why it happens because the other time when I used it, I was confused. I didn't really use unsigned. I mean, I didn't suffix it. Maybe that was the reason why it works for me. So now that I suffix it, something is going on. So I actually suffix it. So even if I use it, so it's giving me warning. So if you should see some blue, sorry, I mean yellow sign ID, it means warning. So I am definitely doing something really wrong. So because I didn't suffix it, you know, the last lectures I told you that you must suffix your value whenever you are using unsigned. So you have to suffix it in order for the compiler to identify your value, that yes, this is unsigned and this is not unsigned, this is something else. Or so I mean, for the compilers to identify your value, so you have to suffix it whenever you are using modify, whenever you are modifying your value. So we actually modify chars and we actually unsigned chars, and we actually put characters 5, which is the variable, and we actually we actually give the value of minus 90, but the other time we did not suffix it, and then it complied successfully for us. Why? Because we did not suffix it. Yes, in this particular place, I mean, in this particular, let me try and remember it again. In this particular section here, and we add unsigned to it, and definitely it gives us error or warning. Let's say warning, because this is warning. When it is yellow, it's warning. So when it is red, it's error. So let's say warning, error. So still closed, and it's not still generating a binary for us. So still the same thing. We are still on the same line. So now you must make sure you suffix your value in order to get your. So the same thing, build with warning. So it's built your value with warning. The other time I was trying to be like, I was confused because I was expecting warning, or I was expecting error. So I was kind of confused, and until I remember that I have to suffix my value. If I did not suffix it, it definitely won't. Maybe compiler can ignore it. Your compiler cannot be really smart enough. So to identify this, and they said, oh fine, your value should be positive and not negative, and you cannot use negative. And probably because compiler is not really smart, like very smart enough to identify our value to be positive, to identify or to take our value as positive. So compiler just do it the way it sees it, and it's just run the binary code for me and give me the binary, which is not right. It is not right. What I should make sure I should do for me as a programmer is to suffix it. So put that note. Always suffix your value whenever you are using or modifying it. So thank you very much about that, and I think we are good here. So let's try and extend our lesson forward. And next thing we're gonna do is that we talk about special characters like escaping sequence. Let's try and go there. There are some to escape sequence. So to escape sequence, like understanding common escape sequence like /n and /t. For you guys that doesn't know what all this means, they are characters. They are char characters. They are used for escaping sequence. So example, let's say now we have this. Okay, let's say we have new line, and we in our lectures, or let's say we have new line again, and we have another new line. So let me try and end this with semicolon, and let me try and end this with semicolon. So on the notes for you guys, I have explained is that if you do not add this angle bracket, the left angle bracket, and use xtdendl, it will fall on the same line. So these two programs here is these two lines of code here is going to fall on the same line in our terminal, because we did not actually end it. We did not actually end the line here. So whenever we end the line here, it's not going to what do the same thing. So if you should run this code, for if you guys have forgotten what that means, so if we run this particular code here, this is going to now strike these two things in the same line for me. Let me just put it. It's going to strike these two things in the same line for me in my terminal. But there is, I'm sorry about that. There is another way you can actually solve that without using xtdendl, which is to end line. You can actually use another method to do that, which are the special or escape sequence which the character provide for us. So we're going to understand what that means yet. So after this stuff run, we're going to understand what that means. Okay, still complaining. I should not complain anymore because, okay, quickly it will complain because I didn't really move the this one, so it should complain. So let me rerun it again. I'm sorry about that. I should actually. So it should not give me error again, because I didn't really move the minus the other time and it's giving me error, and I'm sorry about that for you guys. I'm so sorry. So let's try and run it and let's see what the compiler is going to give us here. Okay, good. So it's built and built successfully, and let's try and clear the terminal and let's run in the code and let's see what is going to be there. Fine and fine. So this is exactly what we expected. See, we have our new line A printed here, and we have the same one. They are all packed together in the same line in our terminal, because we didn't actually, sorry about this this antivirus. Oh, keep running. So we actually have the two compiler. Sorry about that. We actually have the two lines of code being on the same line in our terminal, because we did not end the line here. So there is another method we can actually do to solve this by not using this particular line, end lines of code to end line. So we can only use /n, which means new line. So /n means new line. So /n means new line. So whenever I use /n, it means new line. So let's try and use /n and let's run the code again and let's try and see what's going to be out there. Sorry for running the code one by one. I'm sorry. I just want you to understand this little by little, so you can actually get these particular characters and text. You have to get, for you guys to understand this lecture. So I'm trying to run it line by line as I was doing it. I'm just trying to run it, so in order for you guys to understand that. I'm sorry about that if it is frustrating, if it is annoying. I'm sorry about that. So now we have sign and we have, so good. So now we actually have our line printed in another line here. So we see new line, so we see another line here. The reason why this stuff is like this, because we actually add little space here. So the space is being read by our our output buffer. So our output buffer actually reads everything we have in our code, in our double quotes here, so including this space here. So this two space here, this space here is actually what is being shows up here. If we should close it and run it again, it's going to adjust that, but I won't do that. I'm sorry. So I won't try and annoy you guys. So you can actually do the same thing here by adding /n, which means new line. So we can actually do another one again, which is tab. So tab is where you use /t. /t is tab. So whenever I use /t is tab, and we have another one again, which is backslash. So backslash is when we use this double slash here. So when you use double slash here, it give us backslash here. So sorry about that. Okay, let's try and do something um so I don't really expect error. Or okay, so now let's try and do something. Let's say let's try and use everything we have input here. So now what we're gonna do there is gonna do let's say name. So we're gonna put tab. That's we're gonna put what's your name? Let's see, my name is John Ortega. And what we're gonna do again is that I'm gonna do name. Okay, good. So let's just do something like this. Let's make it really close. So you're gonna see that there's gonna be a difference with that. We didn't add any space to this place, and or let's try and add /n for new line, and let's try and close it. So let's try and do something about this double slash also. \. So now let's try and do something about this. I believe. Sorry for taking your time. I'm just trying to explain what this sequence I'm just trying to explain what this sequence means, escape sequence means, so for you guys to understand what to enjoy the lecture characters and text. So code lab and fine, good. So now we have our code printed from this. Let's start from this particular new line. So new line, which is this one, we had new line to it. It goes properly and it's free for us. We already closed this space we added here before, and sorry, the space we added here before, we closed it, and new line is okay, it's good. And we also have name on the tagger. So we know what tab means. So when we use /t, it give us tab, which I said it is tab here. So it's give us tab, it's tab my name. Yeah, so see the space it gives for it. It's tab. No, I didn't add any space here, and it's tab my name, and I use /n, which is new line, and I use \. So in case, or in order for me to use slash here, I have to do double slash, and I have to do double slash in order to gain the permission to use slash. I think if I just use just a single slash, I shouldn't be have permission to slash. So I have to use double slash in order to gain permission to slash. So I use single slash here. I'm already having compiler error. So in order to use the slash, this particular slash, I have to make it double. I have to make it double in order to have access to the slash. So you see that there is no more compiler error. So so there's no more error, I mean. So that's how to use your sequence, and that's how to use your sequence, escaping sequence. So I hope you guys really enjoyed this part, and I'm going to bring you a little bit more. So a little bit more. I said I'm going to bring you a lot about characters and text, which is char. So now let's try and do something really more. So fine, I'm going to do something like character chars, and I'm going to do like what should I do? Okay, so I'm going to do characters again, and let's just say one, since I have commented them, I can use the the variable again. So let's just say let's say a. So now we say a, the capital letter A, and let's print it. So when we print this stuff here, sorry, I mean okay. So it's gonna be characters of A, and So after this, I'm going to do both for integers, and so for int, for the character, so for int, so I'm going to do for int also. So I'm going to convert it to integer, which is decimal. So then I'm going to do int, and I'm going to put character 1 here. So good. So now I'm going to run my code, or before I run my code, I want to do something again. So now, and this is what I'm going to do. I'm going to declare another new characters. I'm going to declare new characters. So I'm going to say character 1 plus 1. So fine. What this is telling us that we can do, when we said we can do simple math with your char. So now we're gonna do some simple mathematics arithmetic with this stuff here. So now we're gonna say new characters. New character is actually new character. So new character is gonna be, it's gonna be B. Fine, we're gonna know that it's gonna be B, and let's say now it's gonna be for integer part int. So we're gonna do something. Okay, fine. This is simple math we want to do. I actually use char here, and I use variable, and I give the value of a, capital letter A, and oh sorry, errors here. I was wondering what's giving me error. So errors here, I didn't really print. So I put C out, I print it, and C I character, which is character of A, and I do my I print my variables, and which is going to be A, and I convert it to integer, which is going to be the value in integers. And I did character again, I declared new variable, and I summed the chars I had before. I added 1 to it. So now this is the arithmetic I'm going to do here. So I'm going to add to it, and let's see what's going to happen. Definitely it should not give me error. This is a very good code. And oh, bad code. I am so sorry. It has to be single quotes. I use double quotes. I am very sorry about that. I was wondering why is it giving me error, and I didn't know that I added double quote to it. This is a double quote. I'm so sorry about that. So it has to be single quotes, definitely. I was using double quotes. So it's single quotes, not double quotes. Single quotes. So now having single quote to it, now let's see the way our compiler is going to treat our code, or the code we have here. So sorry about why my computer is so slow. I am sorry about that. I apologize, and I hope you guys are really enjoying this sections. So now let's try and check what is here. Slash. Okay, code and lab and fine. Good. Okay, wait. Is it good? Good. Is it good? I think there's. Oh! I did something. I messed up. I am so sorry. I messed up. I am so sorry. I messed up. New character. What is wrong? What is wrong? Okay. I have typographical error here. I have character here. I was still thinking, I was like, what's going on here? I have CHARACTER. Here I have CARTER. I didn't put H. I didn't put C there. I mean, so there is typographical error here, and there is typographical error here, and there shouldn't be here. I am making typographical error again. I'm so sorry about that again. So that's, you have to check your code. Some simple thing can cause you errors, and you try and confirm your code before you finalize, conclude that, oh my god, I am fed up. Try and reassess your code again. So by me reassessing it, I try and notice some typographical errors, and it's even easy for me to notice that because my compiler is good enough and smart enough to identify or pinpoint my errors for me from simple way of just trying to understand what this later. I'm sorry about that. Sorry. Okay, good. Good. Now this is very nice. I did a very simple arithmetic, like I said. We are doing simple math here, just simple math, like we say. Plus 1, we added plus 1 to it, and it increases. It increased our value. Our value in the variable. So in the variable here, I have a, and I added plus 1, and I store the value in my new character, and I print the value at a. By printing the value up here, I said now a is now b. So a plus after a is b. Of course, you all know after a is b. And the next one you have here, shouldn't put this there. It's even interrupting what is here. I'm sorry about that. So now after a is b, and when we have our integer, and our arithmetic 2 is increased from 65, which we have in our integer part, in our integer area. So it's increased to 66. So that is the simple math I want to show you guys. How to use simple maths to char to modify or manipulate single math, modify or use simple math, just simple math. And I want to bring something again. I'm so sorry. I'm gonna enjoy this part. I'm sorry. So now let's try and check, or we're gonna use kind of bowling attitude. So now but it's gonna be car. So let's say car and char. So char is gonna say char. Then let's say chars of characters of a1, and let's do this. Let's choose a, and we're gonna do some conditional statement. Conditional statement is like so we're gonna do is alpha. But before we do that, let's try and include our string. Let's try and include our string in order to have the access to the library. If it is there, so let's try and have to include our string. So then we're gonna say is alpha. Alpha is a function that checks for alphabet. So we're gonna do alpha, then we're gonna put our character here and check it for us. What does this actually mean here? Undefined. It should definitely work. Or is it like this? Is alpha? I'm expecting it to is alpha. It should be string, or what's going on? Anyway, let me just do that for now. Coming. So alphabet is I think there is no typographical error, but I'm just trying. I don't know what's wrong. Definitely, this is a very good code, and I shouldn't really expect error. So this is just normal code, definitely. So alpha is a function in string that check if a character is alphabet or not alphabet. So now I'm gonna say if this character is alphabet, this is what we said. If this character is an alphabet, like what we store here is an alphabet, so it's definitely going to be an alphabet. So we're going to say character is an alphabet. Or let's try and use what we have learned soon here. So we're gonna say else if it is not alphabet, it prints what we have here. And sorry, so I'm gonna say character 1 is not an alphabet. It's not an alphabet. So we can actually have this here stored here and good. So this is a very simple code that tells our compiler, or that shows if we have an alphabet here or not. So notice this is an alphabet. So we are trying to understand more about char here. So now we have string. We have the variable of character 1, and we have the value of a, which is an alphabet, and we have char. So we have a conditional statement. We said if this is alphabet, print what is particularly here, and else if it is not alphabet, go to this and what, print it. So let's try and run this code and let's try and see what we have there. So in this 10, I'm trying to encourage you guys that you can just try to play with this more and more and more and more. So in order for you to understand, and if you don't understand some things there, you can just comment in section. I will answer you as soon as I get my notification. I will give you a very quick answer to that. Fine. So let's try and check what is stored here. So now I'm gonna see what is being stored here. So let's check how our compiler treats our code. So now I said A is alphabet. Oh fine, we all know that A is alphabet. So let's do something really crazy. So let's give it a gibberish stuff. So I added and or I'm sorry, I want to use, let's use asterisk. So sorry about that. I use asterisk. So asterisk is not an alphabet. So let's try and run the code again and let's see what's gonna happen next. So this is an alphabet, which is A. Sorry about that. I didn't really get myself relaxed before I throw myself off. So the A is actually an alphabet and it prints what is here. So we said A is an alphabet, and fine. What if the char here, what if the character here is not alphabet? Let's see what's going to happen here. Okay, so now before this talk ends, I'm gonna interpret something again. So now I'm gonna say again. So let's say it's upper. It's part of function in string. So let's say if it's uppercase, we have let's still I'm coming. Let's try and hold on for it before we print the next one. So now we're gonna do something really new. Okay, asterisk is not an alphabet. Very fine, I love that. This is not an alphabet. It's very simple instruction. We should understand that this stuff you have here is not an alphabet, and our compiler notified us or sees this as the character which is not alphabet, and yes, it throw it in our else statement and print what is there. So if this first one is true, it prints it, and if it is not true, it goes to the next one, which prints S for us. So it prints the first for us. Now this is not true. A is not an alphabet and it's asterisk. Sorry, asterisk is not an alphabet, so it prints the next of all. So let's try and do something else again, and let's make it B. So now let's say if it's uppercase, that's the character A is uppercase. So we're gonna print this one first. We're gonna say character A. So it's upper, that is the name of the function we actually have there. So you're gonna use is uppercase, or we can actually use the new line we just learned soon. Now, and if it's not uppercase, or we can actually do if it's uppercase, or if it's uppercase, we're gonna say it's uppercase, and if it is lowercase, so let's say if lower. So we're gonna do characters of 1 and so we're gonna do something like this here. So it's lowercase. It's lowercase. Sorry about that. The English is awful. It's lowercase. It's uppercase. So now let's try and use something like this, and good. Fine. I actually have two functions there. So I said if it is lowercase, if it is uppercase, print what is here. If it is lowercase, print what is here. Of course, we know that this is in lowercase. This is lowercase. Definitely, it's going to print what we have here. It's going to ignore what we have here because it is not uppercase. And let's try and run it again. And after this, we're going to run another code, and we end up we end the lecture. I'm sorry about that for prolonging this and extending this to this very extent. Sorry, I'm just trying to bring more of examples or samples that we can actually use. So samples you can use, or some examples in our C++ code that we can use with our characters here. So now note that you can store only, like try and remember, you can only store a single characters in your, yeah, that's the only store a single character. You can't store double character. Please don't store double characters or it's going to give you error. And don't worry, you're going to solve that actually. You're going to solve that yourself. So Kotla, so B is alphabet, which we have there. B is alphabet, and the next one said B is what, lower case. It doesn't print B is upper case. Why? Because the function here is error. It doesn't contradict to what we have here. So this is so it doesn't, meaning this contradicts to what we have there. Not it doesn't. It contradicts to what we have there. So I hope you guys get this correctly. So it's uppercase and it's lowercase, print the lowercase, because the B is actually lowercase. It's not uppercase. If you change it to capital letter B, it will give you uppercase. So that's how to manipulate your text actually, with your car. So I hope you guys are getting this. I hope you guys are understanding what we mean or what we are talking about in this particular lectures. And the last one, which is array. I won't really explain much about array, but I will just bring, because we have some example. We have one of our example in it, so that we want to explain. So array usually takes more than one value, but now let's say this is a child, and we have array of, or let's say characters array. And we have for 6. So what this means is that here we have array. I shouldn't really talk about this, but I want to pick some little example from arrays and char. So we can actually store particularly 6 characters of array in this particular case, starting from 0. So that's going to be 7 actually. So your array starts from 0. What this means is that we can actually store more than a single value in a variable. But yeah, you can actually store more than a single value in a variable. Though we said before that we cannot store we cannot actually store double, or we cannot actually have multiple value in a char variable. But because this is an array actually, what array does is that it makes you have access to multiple values by using this static array. So this is just a static array. Like I have a fixed array for you, and yes, I'm going to store more than values. So I'm going to say a, and or let's just say vowel should be a and e, I, o. Sorry about guys. This actually code is an array that we can actually store more than a value in a variable. And to hold the value here, we have to make sure we use our square brackets, and we add our amount of value we had to use there. So after we use that, we're going to use our assignment, and we're going to assign the value we have it there. So inside the assigned value, we're going to have brace initialization, and then we can assign our variable according to our data type here. It is char, which actually allows us to store a single quote value. Usually store a single value in a quote. So we can actually do it in this way, that after writing the first value, we're going to do comma and do it the same way like this. And what is something weird about this is that we have 4 here, and our value doesn't start from 1. It started from 0. So whenever you are declaring stuff like this, your value is going to start reading from 0, 1, 2, 3, 4. So now it should be 5 definitely, because or 6 definitely. So let's say 6, but I'm going to do something for you guys. 6. Why this is like this is because I actually have 6 here. Like I can store like 7 value here, though, but I have 1, 2, 3, 4, 5. I have a verified variable here, which is 0, 1, 2, 3, 4. Definitely it should remain 2 value, and I didn't really use up everything. And the reason is that I use this /0 to terminate the empty space. So here is for a terminator. It's called, actually in a code, it's called a terminator. In an array, it's called a terminator. It ends your particular length of array in as small as there is nothing else again for you to declare, and and your the size of your array is still left behind for you to be used. And once you use this terminator, it ends it. It is something you cannot definitely see. You can't see it. It is in between the back end or your computer. It is in between the memories of your computer. You can never see this. It is your computer that sees what is going on. So it definitely means that you actually leave there are some space, empty space you didn't clear it up, and whenever you use this /t, it clears the memory and terminates this program here, doesn't leave this place here, and it terminates everything here. So whenever you declare stuff like this here, it's going to terminate by using this /0 here /o here. It's going to terminate your programs here for you. So now let's print this out. So we're going to do this. I don't really expect you guys to know for you to get that, so it's not really compulsory for you to get that, but I just want you to see this as one of the features of char. So I'm gonna do something really simple, and let's say C. So I'm gonna do characters. Sorry about that. Oh, I have typographical error again. See, so yeah, I'm gonna print my value. So I'm gonna say it, so let me just print my value directly. So I'm gonna say C and end it. I can definitely end it with stdcn, so it will, or I can print everything in the same line. So let me print it in new line for you. So it's gonna print everything in new line, or if you can either print it in new line, well, let's just print it in single line, and let's leave it like this in single line. It's gonna print everything in single line for us. And if we should run this code, so we're gonna see this particular code printed out. Let's try and print that. So here it's going to give us some simple text, and we're going to check what's going to happen here. So in this particular side here, this uppercase and lowercase, I want to bring you a little bit example. I hope I didn't. Okay, good. So okay, yeah, is alpha. Good, and here I want to comment it. So I'm gonna give you little lectures about that, just little stuff. I told you guys I will end it here. I'm sorry about that. I am so sorry. So I just want to bring this in. It's very important also. It's very important, kind of important. So it's just one of the features of char, characters and text, or stuff like that. So A-E-I-O-U. So we have it all printed. Yes. So now we have access to more than a single variable by using array. So this particular code is called array, but we haven't get to the section we treat or talks more about array. So I would like you guys to take this as part of bonus or stuff like that, because we have the introduction of it in our characters, and I want you guys to relax and chill out. So we're going to explain this when you get to this particular lecture. So now this particular one, I want to bring some little or simple instruction, simple stuff about that thing. So here is it. We have alphabet. So now let's say this is numeric. This is numeric 50. So now let's close this one here and said if it is alphabet, it should print this. What if it is numeric? What if it is numeric? So if it is numeric, sorry, am I right? Numeric. Oh god, okay. I know. I thought I'm gonna get it. I've forgotten numeric. Or numeric. So characters. Okay, good. So now, though I haven't really get this numeric, it's not this long. It's not this long. It's not this long. I think, let me just try and check. Okay, alphanumeric. Um, alphanumeric is alphanumeric. I think it's alphanumeric. So let's try and check alphanumeric. Oh, is it alphanumeric? I think alphanumeric is for those gibberish stuff. So let's try and check. If alphanumeric, let's try and say characters or character one. Sorry. For but alphanumeric. So let's try and check this code. Yeah, we're gonna have error here because I'm gonna have error. I'm so sorry about that. Yeah, we didn't really touch the code. Let's change to this one to character 2. Character 2. And we have VA, and we have character, and we have VA, and we have VA2, and we have VA. So we have 2 here. I mean, I'm so sorry about that. I am so sorry. I know this class takes so long. I am sorry, guys. I am so sorry. I apologize. I'm sorry. I'm sorry. Should I cry? I'm so sorry. Warning. What again? What else happens again? What happens? I deal with this. Okay, fine. Okay, I added. Okay, something is wrong. It's wrong. It has to be. I added single double quotes. I added multiple values in stuff like that. Either I added 30 or whatever it is. So I'm coming. Sorry. Because I added double or multiple value to single quote. That's the reason why I have errors there, and that's one of the reasons why I have error. I'm sorry about that. Okay, so okay, V is lowercase and here is not printed because our character is out of scope. Is not printed. So let's say we have something like this. So our character is not printed because we have get out of scope. We have get out of scope. So now fine, let's check. So 3 is an alphanumeric, meaning that it's an is not in a alphabet, it's alphanumeric. So we can actually count 3 as an alphanumeric. That means we can actually use in characters and special characters and alphanumeric. So 3 is not a alphabet, so it's alphanumeric. So I hope you guys understand what that means. So you can actually use this math. Alphanumeric is a kind of function that is attached to string or text actually. So now we actually get that, and what I want to bring as last one, I'm sorry, this is the last one. So what I actually want to bring as last section is that we can actually convert this lowercase to uppercase. This is what we're going to do. So let's say we declare new a variable and said new variable, new value, and just do character. Then okay, let's say this one we're going to do to upper, and then we're going to do characters of 2. And when we do stuff like this, our value is converted to uppercase. So let's gonna do so this one I'm gonna do as last. I really enjoy. I don't want to end this lecture seriously. I really enjoy this part. I just don't feel like ending it all. So new value. So new value here is gonna have new value. New value is gonna be fine. It's probably for me, or it's good for me if I should I said new line. Oh my god, I mean new value. So it's okay for me is that I put it in a condition, or I said if it is lowercase or not lowercase or whatever it is. No, this is v. So if this v is here, I said v, and this is the compiler is going to check your code. V characters, that's your char character is 2 is equal to v, which is lowercase, and it gets to the next one. I said if uppercase, and if your variable is in uppercase, it's print this. No, it's not in uppercase, it's in lowercase. And yeah, I moved to this particular side here. I said see, I said cars, and I declared new variable for me, and I turned the lowercase to uppercase. I turned this character here, I turned it to uppercase, which is now capital letter V. And I said if it's lowercase, it's gonna ignore this too. It's gonna ignore this. It's gonna ignore this because I have manipulated it. And yes, this is gonna print out for me because actually I just print out. It's not in any condition. I can make it be in condition, but I said if it is in uppercase, print out, and fine by me. Anyhow I want it. So anyhow you want it, you can just do anything you feel like. So it's okay. You can do anything you feel like. I'm sorry, this two data won't print. It won't print this one here. It won't print this one here because I have actually touched something in it which I am not supposed to. Sorry. Sorry about that. So what's gonna happen here is that here is gonna be ignored. It's gonna be ignored also because lowercase, this is uppercase, this is lowercase. Ignore it. Move to this place, change it to uppercase. If it is lowercase, this is lowercase. Ignore it. Then it's gonna print what is here for me. So let's try and check what is gonna happen. What's gonna happen actually? So now I'm gonna say slash code lab, and fine 3 is a numeric. Good. Let's say we are actually done with this, and let's go to the next one. V is a lowercase. V is not lowercase. Of course I changed it. Definitely shouldn't. Okay. I didn't really include the characters here. I didn't mean I used new line here. I'm so sorry. I thought I used new line, so I was confused definitely. Or I didn't use new line here. New value here. I think I use new value here. It's gonna be different. So new value is gonna print. It's not going to print this side for me. I was expecting it to ignore it. I didn't know that I didn't really change the variable here, and I didn't change this one here also. Sorry, I actually excused something here. So now I did something really something bad here. I did not include this new character here, which I was using the old one, which is still small letter. So now I'm sorry, this is the last one. I'm so sorry. I'm so sorry. I'm very sorry. I'm sorry. I don't wish to end this particular lecture. I just wish to just keep teaching. So now we should expect what we expected before and what we are aiming before. Now what I did here is that I didn't really change this new one here, but let's try and see what is gonna happen now. So fine, I'm sorry. Good. Okay, fine. Okay, now cool. I was expecting it to ignore, so it ignored this one for me. It ignored this one for me because now I cannot even use this thing here. If I put it up here, I cannot use. Anyway, fine, it's okay. So what I actually get is that this is lowercase. This is lowercase. Then if it is uppercase, print this thing. This is lowercase. It doesn't print it. I move to the next line here. I said I convert the lowercase here. I convert to uppercase. Then I store it in this new variable here, and I use it here. Which is, I said if it is lowercase, it's no more lowercase. It is now uppercase because I have converted to uppercase. Then it ignores this one and it moves here and print the value. So that's it. That's exactly what happens here. New line is V, which we have here. V. Small letter V is now capital letter V. So I hope you guys get what this thing. So thank you very much for your time and for you ending up the video. And thank you so much. Bye.